Algebra 2, Lesson 3.1a, Solving Quadratics with A and C. Okay. When we're solving quadratics, there's three types of situations that you will come across. Today I'll talk about the first one. I'm going to talk about quadratics that are only going to have A and C. Okay. So I'll give you an example. 4x squared minus 10 is equal to 0. Okay. So when you're asked to solve something like this, right, you have to recognize that this problem only has A and C. Okay, it only has A and C. Right? There's no B value because there's no X. There's no X in the problem, and B is the number in front of X. So if there's no X, that means there's no B, right? So we only have A and C. So when the problem only has A and C, there's a specific way that you go about solving it. Okay, and I'll show you guys in a moment. Example 1 here. Okay. So let's say you get a problem like this. You have to recognize that this is my A right here. This is C, right? It's just a normal number. There's no B in the problem because there's no X. Okay. So when you only have A and C, the way you work it out is you want to get X squared by itself. So I'm gonna do the work to get X squared by itself. I'm gonna minus 1 on both sides. 2x squared is equal to 14. I divide by 2. X squared is equal to 7. Now, whenever you have x squared and you want to cancel out this exponent, right? You want to get rid of this exponent. What you want to do is you're going to square root both sides, right? Whatever you don't do on one side of the equal sign, you have to do on the other. So the square root and the exponent cancel each other, so you're going to be left with just whatever's inside the radical. So it's x. Now, whenever you square root both sides, you have to remember to put a plus minus right, on the side that didn't have the x. Okay, so we're gonna have a plus minus, and then it looks like square root 7. That's gonna be our answer because you can't simplify square root 7. So that's our final answer. Okay. Number 2 here. So once again, you have to recognize when you see a problem like this, like, oh, I've only got A. And I've got C, right, and not a normal number. There's no B in the problem. So if it's A and C, I need to get x squared by itself. I'm going to minus 2. So I get 3x squared is equal to 6. I divide by 3. X squared is equal to 2. Now that x squared is by itself, right, make sure x squared is by itself first. Now you want to square root both sides. Right, so these cancel, so you get x is equal to, don't forget the plus or minus, and then we get square root 2. Okay? Let's take a look at the answers. So some of the questions, next problems here. All right, so example 3 here, this one's a little bit tricky, okay? Whenever you have a binomial being squared, you see this is x minus 3 squared, right? Well, think of this as the a term, okay? So think of this as the a term, and then this is the c. So whenever you have a binomial being squared, and then you only have another normal number on the other side of the equal sign, right? That means think of this as the AC problem, okay? So you just kind of have to remember this type of situation. So whenever you have this, you want to square root both sides, because what happens is the square root and the 2 is going to cancel, right? So we're left with just x minus 3 is equal to, don't forget the plus or minus, square root of 16 is 4. So now that I add 3 on the other side, I'm going to get x equals 3 plus or minus 4. Now since these are like terms, I need to split it up and get the final answer. 3 plus 4, x is equal to 3 minus 4. So I need to continue working it out to get the final answer. X equals 7, x equals negative 1. Okay? So once again, if I have a binomial squared, I have a normal number, right, on the other side of the equal sign. So you have to think of this as an AC problem. So I'm going to square root here, this cancel. X plus 2 is equal to, don't forget the plus or minus. A lot of students forget the plus or minus. Square root 11 and minus 2 on both sides. So x is equal to negative 2 plus or minus square root 11. Now you notice these are not like terms. So you can just keep your answer like this, right? That's perfectly fine. Because if you split it up, now if you want to, you could give me the answer split up like this. You don't have to, all right? Because there's nothing else you can do anyways, because they're not like terms, okay? And then example 5 here. So I recognize that, well, here's A, and then these are just C values, right? So I have an AC problem. So let's get the x squared by itself. I add 13 to both sides. So 3x squared is equal to 20. Divide by 3. So x squared is going to equal 20 over 3. Then I square root both sides now, right? Once the x squared is by itself, that's when you want to square root. So those cancel. Get x is equal to. Now, don't forget the plus minus, and make sure you always put that first. Now, I would write a square root on the top and bottom. So I have a square root 20 over square root 3. Okay, I would write it like this. It's a lot easier to understand it like this. Okay, so let me show you how to approach it once you have this. Now, we cannot have a radical in the denominator, right? You should recall that. So if you continue working this out, what happens is, so we have the x equals, right? Plus or minus. Square root 20, that's 2 square root 5, right? If I simplify square root 20, that's 2 square root 5. And I still have the radical 3 in the bottom. Now to get rid of this radical 3, I'm going to rationalize the denominator. What that means is I'm going to multiply the top and the bottom by whatever the bottom is, square root 3. Okay, so my final answer, I'll write it up here, running out of space. So x would equal plus or minus, so 2 square root 5 times square root 3 would give you 2 square root 15 divided by square root 3 times square root 3 is square root 9, which is just 3. Okay, so that's the reason why we do this step right here, is because it gets rid of the radical in the denominator. You're going to just end up with, right, if you have square root 3 times square root 3, your answer is going to just be a normal 3. Okay, because we cannot have a radical in the denominator. Take a look at example 6. So once again, here's my A, here's C, right? So it's an AC problem. I need to get x squared by itself, minus 3. So 5x squared is equal to 4. Divide by 5 on both sides. X squared is equal to 4 over 5. I square root now. So x is going to equal, don't forget the plus or minus. Now the square root of 4, if I write this right, square root 4 over square root 5. Well, square root 4 I know is going to be 2, right? So I'll continue this up here. So x is going to be plus or minus positive 2, because that's square root 4, over square root 5. Now I can't have square root 5 in the bottom, so I'm going to rationalize the denominator. So I get x is equal to plus or minus 2 square root 5 over 5. And that's my final answer.